Welcome to the Math Record. For the second part of the Math SAT series, we'll be learning about the content covered in the Math SAT. In the Math SAT, there are three main sections: harder algebra, problem solving and data analysis, and passport to advanced math. If you need any help in any of these sections, there are practice tests for the SAT on the internet. We at the Math Record are also making future videos related to these concepts, so watch out for those videos when they come out. Let's start with Heart of Algebra. This section is the easiest of the three and mainly tests students on solving equations or inequalities, interpreting linear functions, and solving systems of linear equations. First up, solving equation or inequalities. For these types of questions, you want to isolate the variable, then solve the question. For example, let's take linear equations like 2x minus 5 equals 13. For first, we want to take out the constant first from both sides, so we have to add 5 to both sides. So that would make 2x is equal to 18, and which isolates the variable x. So then divide by 2 from both sides to get x is equal to 9. The same case could be applied with inequalities. So we take the same case, 2x minus 5 is greater than 13. Add 5 to both sides to isolate the variable, and then divide by 2. So x is greater than 9. So for equations, there's usually just one answer. And for inequalities, usually there's a range of answers. So for this inequality, any answer greater than 9 is the answer. Next up is interpreting linear functions. The general form for a linear equation is y equals mx plus b. M would be considered the slope, while b would be considered the y-intercept. The slope is usually referred to as a unit of y per unit of x, and the y-intercept is the value of the y units if the x is equal to 0. So when x is equal to 0, and you plug that into the equation, then m times 0 is just 0, so y is equal to b. So when x is equal to 0, then the y-intercept would just be b. If you need further help with any of these concepts, the Math Record will be releasing Math SAT practice exams in the future, so check out those videos when they come out. And the last topic in harder algebra is solving systems of linear equations. For these type of equations, you most likely want to use the elimination method. For two variable systems, let's take for example, 3 3x minus y is equal to 5, and 2x plus 3y equal to 7. Since you notice that there's a negative y on one side and positive 3 on on the other side, you want to multiply the first equation by 3. So then when you add them together, the y variable cancels out. So usually when you see these questions, there's usually a negative version and a positive version. You want to add them together. So you want to make the constants the same. So you have to multiply the first equation by 3, which makes 9x minus 3y equal to 15. Just multiply 3 here and multiply 3 here. Now for the second part, you want to add these two equations together. So then the 9x plus 2x is 11x. And the negative 3y cancels with the 3y. And the 15 plus the 7 equals 22. So x is equal to 2. Now if you plug in 2 back into the equation, that makes 6. minus y is equal to 5. So y is equal to 1. So for the solution for this equation is 2 comma 1. You could also plug in 2 to here to make 4 and do the exact same process. Both of these equations would get you the answer for y. I just use this one because it's the easiest since this one is just a singular y. So this is only for a 2-variable system. For like a 3-variable system, which a 2-variable system will have an x and a y. A 3-variable system will most likely have an x, y, and z, or 3 different variables like a, b, c, or something like that. I'm not gonna cover the 3-variable system because usually the SAT doesn't work with those because it takes too much time, and since you're on a time crunch, and SAT doesn't want to just want to test you on the basics to see if you understand your concepts. Now, now that we're done with harder algebra, the second section is problem solving and data analysis. This section isn't really hard, but mostly students get these questions wrong because they might have misread or made a mistake. So to avoid these mistakes, I advise you to just practice more so you recognize when you're doing these mistakes. This sections will mainly test students on ratio, rates, and proportions, linear and exponential growth, center spread and shape of distributions, and data inference and collection. First up, ratio, rates, and proportions. This section deals with understanding anything proportion related. Rates are just slopes, so understanding slope as explained in heart algebra, heart of algebra would just be enough. Proportions and ratios are roughly the same. For example, if 1a is equal to 2b, then what is 3a equal to? Usually what I'll do is that I usually use fractions. So 1a over 2b is equal to 3a over the question mark. So uh, what number would you get from 1a into 3a? What you want to do is you want to multiply by 3. So 1a times 3 is 3a. So to keep this in the same ratio, that means 2b has to be multiplied by 3, which makes 6b. So question mark is equal to 6b. Next up is linear and exponential growth. Linear graphs increase at a constant slope. So they look something like this. Or anywhere, it just looks like a straight line. Or it could look something like this. Or maybe it has like a growth that isn't doing anything. Something like that. Another uh an exponential graphs look like this. They look like curves. So this would be an extra exponential growth. If it's going down this way, it will be an exponential decay. Usually in these forms, usually for exponential graphs, the form is equal to y equals a times um the rate, which I'll write as r, to bx. These are my own variables that I made up. So your teacher might teach you differently, but they all have a general they all have the same purpose. A would be the initial amount initial amount in beginning. So when r is equal to 0, I mean when x is equal to 0. So let's say you're in your population, bacteria started at an initial population of 100. Then A is equal to 100. Okay? So in our scenario, A would be equal to 100. And let's say it's increasing by a rate of 20% per year. So that would be equal to, rate is just 1 plus the percentage. So it's 1 plus 20% is 1.2. I mean, that's R. Sorry about that. R equals 1.2. And B is just a random number. It's just a random number that you plug into the equation so you can speed up the graph. Imagine like B is 10. That means uh it will work faster than the equation that is just when B is 1. So let's say 100 times R to the power of X versus 100 times R to the power of 10x. 10x will move way faster. Let's just, for example, plug in X equals 1. That means R is going by a power of 10, while the initial one will be R to the power of 1. So you see how fast it's going? But if it's like lower, let's say 0.5, it's going at a slower rate. So what we're doing would be the graph. Let's say this is just this is y equals rx, then r equals 10x would be something like this. Sorry, it looks bad, but like this. We're going at a really steep slope. So it'll be going up super fast, while this one will go up super slow too. But they're still both going up. Um Usually they will ask these questions about exponential growth in these forms. Another, instead of the rate, would be a different form they'll put is y equals a to the power of e r t. Or usually when people call it, it's not a, it starts with p. They're both a constant. It's just called pert. So a would be the initial amount. E would just be the continuous growth. This is this is a continuous growth. It just models real life equations better. It's not really special. Instead of R being like any single variable number, like increasing by 20%, E would be 2 2.718, or roughly around this amount. So it's just a thing. If they ever ask you questions based on E, most likely they're gonna ask you in a calculator question. So you might want to just use a calculator. Another reason would be like if it's just a general form of the equation and they're not gonna really ask you about numbers, they're gonna ask you what does E mean. E would mean is compound continuous. That's what it means. And T would be the same thing as B in this case. And R would just be the X, would be the variable. I mean, T would be the X, and R would be the B. Next up, center, spread, and shape of distributions. This section is just more about memorizing than anything else. Center consists of medium and means. So these are made of means and medians. So means are just the sum of the group of numbers divided by the amount there is. So let's say you have a group like 1, 2, 3, 4, and 5. The mean would just be like adding all these numbers. So 1 plus 2 plus 3 plus 4 plus 5 would be 15 divided by the amount of numbers. So 1, 2, 3, 4, 5. So there's 5 numbers in this group. That equals a 3. So the mean is 3. The median would be the middle number. So it'd be, if you put this in order from least to greatest, the middle number is 3. So that's what they call as the center. The spread, there's 3 different kinds. There are 3 main kinds. Other than that, I don't know any single one else. There's IQR, there's range, and there is standard deviation, which I'll represent by SD. IQR, if you ever seen like box and whisker graphs or box plots, they have something like this, where the smallest data is here, the biggest data is here, and this is where 25% of the data is, this 75%, and this is the mean, or at the median. Usually the IQR just means from the 25% to the 25% to the 75%. Sorry, trying to make a line. I mean an arrow. So from here, the 25 to the 75%, that's the IQR. The range would be from the max to the min. And standard deviation would just be the sum of all numbers from the mean. This is actually a way more complicated formula, and my explanation might not be as correct, but that's basically what it is. So IQR, let's just say we'll use a group like 1, 2, 3, 4, 5, 6, 7, and 8. The IQR would be the 25%, which is this number, 2, and the 75% would be 75. You will use this with percentages because um, one one number out of 8 numbers is 12.5. So the next number has to be 25%. So 2 numbers, the second lowest number out of 8 total numbers is 25%. Or the second highest, which is the 7th, I mean, uh, wait, 8. Or the 7th highest number, which is the actually oh yeah, that makes sense because like the second number from 7 would be 5 in the basic gist of numbers. I might be wrong, but you kind of get the gist of how it works. So from the middle, like 25% to 75% of the data, that's where it is. The range would be the max and min. So 8 and 1, that makes 7. So 8 minus 1 is 7, or 7 minus 2 is 5 for the IQR. Standard deviation would just be any number distance from the mean. The mean is like 4.5. So the standard deviation would be um standard deviation would be probably 4.5. I might be wrong, but let's just assume the standard deviation is 4.5. So that's what it is. From the distance from the mean. Because usually it's 8 and 1, 7 and 2, 6 and 3, and 5 and 4. So all of them have like a mean of 4.5. So since it's already in this order, I assume that standard deviation will be 4.5. That makes sense a lot. You usually don't need to know what standard deviation is, like how to calculate it. This is usually a term used in stats if you're ever gonna take the class. So it's just mostly supposed to like calculate the variation from like the mean. Like how what they use these numbers for is to say like let's say you flip a coin, right? And you do that 50 times. It's pretty not uncommon if you have like 25 heads and 25 tails because it's a 50-50 chance. But what happens if you have like 30 heads and 25 and 20 tails? Is that uncommon? What happens if you make 35 versus 15? See that there should be numbers that help you calculate if it's really awkward. Like let's say you say 25 and 25 is not unbalanced. But what about like 27 to 23 to 30 to 20? Like there must be a certain point which tells us that the spread is unusual, where you can start seeing these patterns that fluctuate way too much. So that's what I do. What these calculations do. Um, Now let's look for shape. There's only mostly two kind of shapes. Uh, Sorry. There's mostly only two kind of shapes. There is a normal model, which kind of looks like a curve right here. It kind of looks like a reverse parabola. I mean, it kind of looks like a parabola, but like these the endpoints kind of like curve back down, so it kind of like never goes negative, but goes on these positive. and these are symmetrical. It might not look like it, but symmetrical. This is where the mean is. The line right here is the mean. So, and everyone else is like calculated by standard deviations. So this is one standard deviation away. This is two standard deviation away. This is three. Same case here. This is one standard deviation away, two standard deviation away, and three standard deviation away. And that's why I said about like this is using a stats. This is what they use, a normal model. So a normal model is symmetrical. And then there is another type of model, which is called a bell curve. This model like is called uh, a bell curve to the right because the tail right here is moving to the right. So usually if this is a normal model, the mean would be right here. But then since there's these bell curve, the mean is getting dragged over. So that's why the mean is greater than median. So the median would be like right here, while the mean would be like right here. See? Get it? And let's say and then there's another type of model which is called a bell curve to the left. Because like if the mean, if let's say a normal model is right here, right? Then the mean is supposed to be right here. But then since it's getting lower, the mean is getting dragged down. So this is where the mean is. But then the median would be like right here. See? So the mean would be less than the median. So these call like bell curves because they're kind of curved, while this is more normal. In the SAT, what they like to usually do is that they mostly use mean and median for like centers, so that's about equal chances amount. But when they use spread, they're mostly gonna talk about range or like IQR. Standard deviation not as much because people don't know about it. But but they do sometimes test on it. So then when they ask about like they let's say you have a group like 1, 2, 3, 4, and 5, and they add 2 to each group, they're gonna ask like how much does the center change? For the center, that let's say you add a 2 to each of these numbers, then the center increased by 2. So if you add 2 to every single one of these numbers, so this becomes a 3, a 4, a 5, a 6, and a 7. Then the starter increased by 2, which makes sense because then the 3 turns to a 5. A spread, the spread doesn't do anything. So nothing happens to a spread if you're adding things. Nothing happens. Okay? And now let's say you multiply all these numbers by 2. So this becomes 2, 4, 6, 8, and 10. The center will multiply by 2. You see how that makes sense? Because then 3 would become 6. Yeah, you gotta multiply the center by 2. Also, for spread, you also multiply by 2. Both of these has to be multiplied by 2. So remember, when you're adding, only affecting the center. If you're multiplying or dividing, you're only affecting the you're you're affecting both the center and the spread. Also, if you're subtracting or anything familiar to adding to subtracting, then basically that you're only affecting center. Anything multiply, dividing, or anything really close to that, then basically it's spread. I doubt they're gonna ask you what happens when they're like square rooting or rooting equations. There are really weird phenomenons when you're happening. Like what happens if you add 3 standard deviations together. I won't be teaching you those because it's a little complicated, and I don't think the SAT would be teaching you those. It's not the same thing as adding or multiplying. So if you think it is, it's not. If you want to learn more about that, you could like we'll be releasing future videos on stats that covers this material. But you can also learn in school if you're taking stats as a course. But mostly this is just about memorizing. Remember I just said that in the beginning? You just gotta memorize what centers are, what spreads are, what shapes of there are, and memorize like what happens when you what happens when you add numbers to a group or multiplying. Uh, and now and now data inference and collection. Usually these just use tables or graphs. You guys know how to do this. So mostly just like the table This might be a really simplified example, but what it'll use is like this. So you have like some kind of variable, let's say like I don't know, like height, and this is like width. And then they're like height 1, height 2, weight 1, weight 2, and it gives you like 4 random numbers, and they're just asking you to evaluate the table. And that's basically what it is. It's really basic. Just look at the data and understand what the questions are. When we're gonna practice like practice exams, I'll be explaining this further. Um, Also for graphs, mostly for graphs, they're just gonna ask you about like actual graphs, like parabolas or linear equations, such as like this. If for a parabola, they're gonna ask like what's the min or max, or like if it's going something like this, they're gonna ask you about the zeros. For linear equations, they just might ask for the x-intercept or the y-intercept, or basically just the slope. But mostly when they're asking these questions, they're gonna ask like scatter plots. So what they're gonna do is like, what is like the correlation? Is it positive? Is it negative? Or is it zero? And we'll be covering that in our practice exams too when we're gonna look at these questions so you understand it better. Um, and now finally, passport to advanced math. Now that we have finished problem solving and data analysis, let's tackle practice passport to advanced math. This section is most likely the hardest of the 3 sections, but it's not that much harder. It just covers like the harder sections. The math topics in this section are radicals and exponents, operations with rational and polynomial expressions or equations, and linear and quadratic systems. For first up, radicals and exponents. Exponents, you just need to learn the rules. So if they have the same base, you can start multiplying in exponents and start adding them. So let's say like 2x times like 2y. Then this is just 2x plus y. This is an exponent. X plus y is an exponent. The same case if it's 2x divided by 2y. So instead of adding, you're subtracting. So it's 2x minus y. A third one would be like 2x the power of y equal to 2 times x times y. So that's basically what it is. You can also just change it so 2y and the parentheses x is the same thing. So, but for dividing, for adding, for multiplying is also the same. It's just think about it, you're just adding. But subtracting, you have to be in the right order. So you can't say 2y divided by 2x is equal to 2x minus y. It's 2y minus x. So x is the first term, y is the next term, and you have to put the subtraction sign in the between. Self-explanatory. Radicals do the exact same thing, but now they're just fractions. So if you have like a square root 2, square root 2, 2, what this is equal to is just 2 to the power of 1/2. So it's working with the power 1/2, which is just working with like exponents. So it has the same rules as x plus y. So let's say you have square root 2 times square root 2. That's just 2 to the power 1/2 times 2 to the power 1/2. 1/2 plus 1/2 is just 1. So the answer is just 2, which makes sense because square root 2 times square root 2 is just 2. Next up, operations with rational and polynomial expressions or equations. Let me erase this. Uh, these questions just mostly deal with quadratics. So you have something like 6x squared. Sorry, my 2's in my handwriting is bad. 2 um plus x plus 5 is equal to 7. Then you want to get all these numbers to one side, so the other side is 0. So 6x squared plus x minus 2 is equal to 0. Why do I get this to this side than the other side? Like, why won't I subtract 6x squared? The first reason is because it takes a lot of work to do 3 of them instead of just 1 here. So, and another reason is that I want to keep this term positive. But it's just easier to think about. usually for the SAT, like for these terms, they're gonna factor out really nicely. So what I usually do is that when I see a 6, I usually don't choose 1 times 6 or 1 times any of that original number. So if this is 3, I won't I mean, if it's 4, I won't choose 1 times 4 because for some reason I really think it's unrealistic. What the SAT wanted to do is that they want to like factor out so you understand the content better. So they usually choose like numbers which is like 6, which is just like 2 times 3, which is like the only other way to do it. So what the usually it is like some numbers like that. Usually it's not 1 times that original number. So 3x parentheses 2x. So this is usually what I would do. And then I'll find out what numbers multiply to -2 that multiplies to these when those factors multiply to these numbers add to 1. So we have a 2 and a 1. So the only way to get that 1 would be like 1 is a 4 and 1 is a -3. So so this one is +2 and this one's -1. So all these factor out correctly. So that makes a 6x squared, that's -3, that's 4, so that adds up to 1, then that's -2. And this all equals to 0. So x here would equal to -2/3, and x here would equals to 1/2. So those are the answers. Read the questions for the SATs for these type of questions, because usually when it's free response, they're only gonna ask for one answer, so be sure to read it right. So ask them if they're asking for positive, then choose 1/2. If they're asking for negative, choose -2/3. For multiple choice, I won't be as concerned because usually they ask for both answers, so mostly just put them down. I mean, it's in the multiple choice. Just look for it. Um, and finding linear and quadratic systems. Questions like these are like basically the exact same as the previous one. So usually like 2x squared plus 4x plus 3 is equal to like x squared plus x plus 1. Like I taught you before, just subtract like all of them to one side. So this would be x squared plus 3x plus 2. And then you want to distribute out. So x plus 1 and x plus 2 equal to 0. So the answer is x equals 1 or -2. Other than these main sections, there are also minor sections. This includes formulas and theorems related to shapes. I'm not really as worried as much because for the SAT, there's always a for calculator and non-calc, there is a formula sheet in the front page. So if you just follow the formula, then you'll get it right. These are just really basic. So mostly the shapes they're gonna use is triangles and circles, but it's good for you to remember like specific triangles. So then for like let's say an equilateral where all three sides are the same, then all three angles are 100 are 60 degrees, all of them. So for equilateral, all three sides are the same and all angles are the same. Um, if for isosceles triangle, only two sides are the same, and these have to be the same angles. Both of these at the bottom, correlating with the sides. And this angle, might be the same, might not. If this angle is also x, then it's an equilateral. If it's not, then it's just called an isosceles. Okay. For special right triangles, you just basically need to know the Pythagorean theorem. So it's like if this is a right triangle, then you should just know like 3, 4, and 5 is a right triangle because 3 squared plus 4 squared equals 5 squared. Because that's 9 plus 16, which is 25, and 5 squared is 25. Uh, Also, when you are dealing with like trick questions, there's okay. There's basically 6 of them that you might need to know. There's sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. Sine of x is just let's say we'll call this b. It's just b over the hypotenuse. Uh, So that's what it is. It's just b over h. For cosine of x, it's just a over h. For tangent of x, whatever the angle is just b over a. If it's like an angle here, then it's a over b. So sine of x, if this is x, then this will be a over h. It just depends on how you're going to look at the triangle. So a sine of this angle would be b over h, and the sine of this angle would be a over h. Same case applies to every single one. So cosecant of x is just the reverse sine. So just reverse this. So this would be h over b. Usually for sine, cosine, usually these are just less than 1. So they could be negative depending on how the unit circle goes, but these are usually less than 1. Or it's between -1 and 1. That's what these numbers are. Tangent could be like any number. Cosecant is could also be any number, and secant is just like reverse cosine is h over a, could also be any number, and cotangent is a over b. It's just reverse tan, so it's also be any number. So only sine and cosine are the ones that are limited. But if it's just so if you want to remember cosecant, secant, and cotangent, cotan, like just tan, then it's just reverse tan because you already know tan. So cotan is the reverse tan. Secant is with cosine, so it's h over b, and cosecant is with sine. So the trick that I learned from my teacher is that each of these names have a secant. So this one is sine, and this is cosecant. So this one has to be with the sine. Secant and cosine. So secant is the one with the secant, would go with the cosine. And then cotangent, and this is tangent. So you already know that. But basically, if you know secant goes with cosine and cosecant goes with sine, then you already know how all these trick works. Mostly, I think they're just gonna ask you about sine, cosine, tangent, because these are the only ones that are like really matter. Because these are just basically other functions that has real value, but to like other concepts rather than just trig. Um, Also for like trig, you usually want to draw a picture out when you try to like do these questions. It's much easier. Anyways, let's stop studying for today. We made a lot of progress. If you want more information, check out the links in the description below. The next video will cover practice exams that will help you tackle these problems specifically, so look out for those. I recommend you try some practice exams on your own before watching these videos. It's better to know what the content is about first so you'll be able to understand what the video is about better. I'll link some practice exams in the description, so be ready for the practice exams for part 3 of the series. Anyways, thanks for watching, and I'll see you at the next math record video.